Okay, hello year 4 students. I'm here to address a misconception that this question here is a very recent question, last year's MCQ from the O-levels. Alright, so this question sort of points out a misconception that may exist among some of you year 4 students. So I suggest you pay attention to this video, right? So what I suggest you do is you pause the video here and you try this question yourself, right? Alright, so you pause now and I'll carry on after you have tried the question. Okay, I've assumed you have tried the question. Okay, so I'm going through the question. There's a hydraulic press with two pistons, right, which looks very standard, right? Pressure on piston 1 exerted by the oil is P1. So P1 is the pressure that is pushing the piston 1 upwards, right? Pressure on piston 2 exerted by the oil is P2. Pressure at point X is P, right? So this point is P. How does P1 and P2 compare with P? Right, so if you look at your textbook on page 130 where you study hydraulic press, alright, it says something to the degree that a force F1 or Fx acts on piston 1. The pressure at point X in the liquid is given by Px equal to Fx over Ax, where Ax is the area of piston 1, and this pressure is transmitted equally to every part of the liquid. Okay, so this is on page 130 of your textbook. Okay, but I'd like to stress that when we talk about this pressure here, there's equal force over area, right? So normally if I exert a force here, right? So normally if I exert a force here, right, then I'll say, oh, the pressure in this liquid here is equal to the force over the area. Okay, what I'd like to say about this pressure here is that in your textbook it says that the pressure is transmitted throughout the liquid. So every point, right, has this pressure P. Right, what I'd like to clarify is that this pressure, right, is actually a change in pressure due to the force. That means this pressure is a function of this force. Right, if there were not a force here, right, if there were not a force here, would there be a pressure here? Right, the answer is actually yes, right, it's atmospheric pressure lah. If I assume the piston is massless, right, because atmosphere still exerts a pressure on the piston. If I assume piston is massless, then the pressure at this point must be atmospheric pressure, right? So what is the pressure at this point, right? It must be atmospheric pressure plus this height, right? And if I want the pressure is given by H rho G, right? So if what is the pressure at this point X, right? So this is the height associated, right? I call this H2 lah. This is called H1, right? Right. So this is the pressure associated at this point. If I want to find the pressure at this point, right, it will be this one plus atmospheric pressure, right? Because this pressure will be the same as here, right? These 2 points are the same pressure. So what's this pressure? This is H2 rho G multiplied by atmospheric pressure above, right? So you can see that if I'm looking at the pressure inside the fluid, this point has higher pressure than this point and this point. Alright, and so the answer is actually C. Alright, but when you do a hydraulic press question, normally you don't care about the pressure at this point, or this point, or this point. You just care about the pressure due to the force, right? So the pressure due to the force is given by this formula, P, right? Let's just call this X lah, our piston 1. Okay, P1 equals to F1 divided by A1. You only care about this P1, and this P1 is transmitted throughout the fluid, and it's exerted at this point, right, to produce an outward force here, right? So this is still P1, right, the same P1 as this P1, but remember I said again, this P1 is not the pressure at this point or the pressure at this point. This P1 is a pressure from the force. You can think of it as a change in pressure, right? So instead of saying the pressure throughout the fluid here is the same, I would rather say that the change in pressure throughout the fluid is the same, and the change in pressure from piston 1, right, comes out in piston 2, which, right, associates itself with an outward force on piston 2 that's associated with the area of piston 2. Alright. So when you're doing a normal hydraulic press question, don't worry, you're still doing what's right. Just know that is this P here that you say is throughout the liquid, right, is the change in pressure. The change in pressure is transmitted equally throughout the liquid. Alright. It is not true that the pressure throughout the liquid is the same. Right, the pressure throughout the liquid can be different, right? In fact, the bottom pressure should be higher than the top pressure. Okay, so with that, I'll end this video.